This class we discuss about quality factor of parallel resonance circuit. Already we derived the quality factor for a series resonance circuit. Quality factor Q is equal to 2 pi into maximum energy stored in the inductor or capacitor divided by energy dissipated per cycle. You know it very well. Energy stored in the inductor is Lim square by 2. Energy stored in a capacitor is C into Vm square by 2. Energy dissipated per cycle, that is equal to Im square into R divided by 2 into T. T is the time T is equal to 1 by F. Here IRM is equal to Im by root 2. Q in terms of inductance, Q is equal to 2 pi into energy stored in the inductor of into Lim square divided by R into Im square by 2 divided by F. Okay, you simplify it. Q is equal to omega into L by R in terms of inductance. Similarly, in terms of capacitance, Q is equal to 2 pi into energy stored in the inductor C into Vm square by 2 divided by R into Im square by 2 divided by F. Again, you simplify the equation. You got Q is equal to 1 by omega into R into C. That is Q in terms of capacitance. Similarly, we derive quality factor of parallel resonance. Current through the inductor is equal to Im is equal to Vm by XL. XL is equal to omega into L. The formula is L into Im square by 2. Im square is equal to Vm square by omega square L square. Therefore, energy stored in the inductor is Vm square by 2 omega square into L. Okay. Energy dissipated per cycle is equal to Im square into R divided by 2F. So Q is equal to 2 pi into Vm square by 2 omega square into L divided by Vm square divided by R into 2F. Again, you simplify the equation. Q is equal to R by omega L in terms of inductance. Similarly, in terms of capacitance, 2 pi into 0.5 into C Vm square divided by 0.5 into Vm square by R square into R into 1 by F. Again, you simplify it. You will get Q is equal to 2 pi F into R into C. 2 pi F is equal to omega. Therefore, Q is equal to omega into R into C. Q in terms of capacitance. Here, in series resonance circuit, Q in terms of capacitance is equal to 1 by omega into R into C. In parallel resonance circuit, Q in terms of capacitance is equal to omega into R into C. Q in terms of inductance in series resonance circuit is equal to omega into M by R. In the parallel resonance, Q in terms of inductance is equal to R by omega into L. Now we discuss about bandwidth of parallel resonance circuit. So this is the parallel resonance circuit. Admittance Y is equal to G plus JB, where G is the conductance, B is the susceptance. Y is equal to 1 by R plus 1 by J omega L plus 1 by J omega C. Y is equal to 1 by R plus 1 by J omega L plus J omega C. And rewrite the equation Y is equal to 1 by R plus J into omega C minus 1 by omega L. At resonance, omega R into C minus 1 by omega R into L is equal to 0, or omega R into C is equal to 1 by omega R into L. I simplify the equation. Omega R square is equal to 1 by LC. Omega R is equal to 1 by root L into C in radians per second. Our resonant frequency Fr is equal to 1 by 2 pi root L into C in Hertz. So this is the graph. X-axis frequency, Y-axis V. This is V maximum, 0.707 dB maximum. This is lower half power frequency. This is upper half power frequency. This is the resonant frequency. Now we calculate the bandwidth. Bandwidth is equal to omega 2 minus omega 1. Omega 1 is the lower half power frequency in radians per second. Omega 2 is the upper half power frequency in radians per second. First we calculate lower half power frequency. Here Xc is greater than XL. Therefore, omega 1 into C minus 1 by omega 1 into L is equal to minus 1 by R. I simplify the equation. Omega 1 square into LC minus 1 is equal to minus omega 1 into L by R. So, omega 1 square LC plus omega 1 into L by R minus 1 is equal to 0. I divide both sides by LC. Therefore, I got a quadratic equation omega 1 square plus omega 1 into 1 by RC minus 1 by LC is equal to 0. I got two roots. So, omega 1 is equal to minus 1 by 2 into RC plus root of 1 by 2 RC the whole square plus 1 by LC. Negative angular velocity is not accepted in engineering, not possible. Therefore, we neglect it. This is omega 1. Next we calculate upper Hausdorff frequency. In this condition, XL is greater than XC. Therefore, 1 by omega 2 into L minus omega 2 into C is equal to 1 by R. Again I simplify it. I got 1 minus omega 2 square into LC minus omega 2 into L by R is equal to 0. I divide both sides by LC. I got a quadratic equation. Minus omega 2 square minus omega 2 into C by R plus 1 by LC is equal to 0. Now I can calculate omega 2. Omega 2 is equal to 1 by 2 RC plus root of 1 by 2 RC the whole square plus 1 by LC. Therefore, omega 1 is equal to minus 1 by 2 RC plus root of 1 by 2 RC the whole square plus 1 by LC. Omega 2 is equal to 1 by 2 RC plus root of 1 by 2 RC whole square plus 1 by LC. Bandwidth is equal to omega 2 minus omega 1. Omega 2 minus omega 1 is equal to 2 divided by 2 RC. 2 to get cancelled. The bandwidth omega 2 minus omega 1 is equal to 1 by RC. Thanks for listening.